Okay, hi guys. So, what we're gonna be doing in this video, we're gonna start with reviewing absolute value functions, right? Um, so, this is, I believe, part 2 or part 3, something like that, because I know that I put a video up. Let's see, give me a second, guys, I'm gonna look really quick. Okay, so this is part 3. Or no, part 4, excuse me. So yeah, this is gonna be part 4 of the review. And what we're gonna start with is absolute value functions. Now, I would do absolute or quadratic functions, but absolute value functions are, from when I did college algebra, absolute value functions were probably second after linear functions. So we're going to go ahead and do absolute value functions. We're going to review them very quickly. So remember, like, if you're reviewing, or if you're barely looking at this, I would recommend that if you're barely looking at this, I would recommend that you look at my video on absolute value functions, because this is going to be very brief. But from what we remember, and if y'all hear background noise, I'm sorry, guys. It's my sister's talking. Okay, so absolute value functions. If you don't know what absolute value functions are, of course you can go and look at my video. But I have a whole playlist of algebra, and in there is absolute value functions. So basically, from algebra, they taught you that there's a specific form of absolute value functions called vertex form, where you have a times the absolute value of x minus h plus k, and so basically, a is your slope, h is your, I would say, axis of symmetry, and then k, well, basically your vertex is hk, right? And when you graph the parent absolute value function, y equals the absolute value of x, if we do a little table here, an x and y table, we can say, well, if I have -3, -2, -1, 0, 1, 2, 3. And this, by the way, is going to be all about absolute value functions, like in terms of equations, inequalities, etc. Because obviously, I don't want to make, I don't want to just leave every part for, a video. So this is going to be, so basically we have the absolute value, and we have the absolute value -3, of course, and then we say, okay, well, that's, we can have a negative in the absolute value. It's just going to be 3, so we have 3 right here. And then the same for -2, with the absolute value of -2, we can't have a negative, right? So it's going to be 2, and then the absolute value of -1, that's really the positive, the opposite, so it's +1, and then 0 is just 0, and then 1 is just 1, 2 is 2, 3 is 3, right? And when you graph it, and let me go ahead and just draw this very quickly. When you graph it, you have something, so you go So basically, it's something like this, and, you know, obviously, you would do 1, 2, 3, and of course it doesn't have to be a really big graph either. I know I made it a little too big, but we can put more points if we wanted to. So we have 1, 2, 3, 4, 5, 6, so -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, right? And then we have 1, 2, 3, 4. So let me go ahead and just finish. Okay, so we have -3, 3, right? So right here, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3, right? And so what you do is you go ahead and you trace a line, a vertical line on both the on both of these parts, right? And let me just make sure that it's okay. And this would be your absolute value function. So basically, this is y is equal to the absolute value of x. This is a parent function, okay? This is what we call the parent function for the absolute value function. So parent function for the absolute value function. Now, to quickly define what the absolute value function is, f of x equals the absolute value of x is really f of x, and we can denote this as a piecewise function. And I know that, I don't know if I went over piecewise functions. Maybe I did, I can't remember. But really, it's -x such that, and we can say, because this highlighted part here, if you think about it, this highlighted part here is really -x. It's -x such that x is less than or equal to 0. And it's positive x, and positive x is another one. So positive x is over here, right? Such that x is greater than or equal to 0. Now, what you want to do is, I mean, in reality, you would want to just go ahead and say, okay, you know, they would want you to just say the absolute value. I don't think that they would ever tell you, oh, go ahead and like try to change it to a piecewise, because that wouldn't make sense. I don't think they ever told me to do that with absolute value functions, so I don't think they should like say, oh, do it that way. So that, but that's just the definition. That's how they would say, well, it's really just this. It's really a piecewise function. They want you to know that. And they want to make sure you understand that it's really just a piecewise function. So, but like I said, you don't have to, like, when you graph absolute value functions, you don't have to actually, how do I say this, like, change it to piecewise and then graph it, because that would take too long. So, with that being said, we're gonna graph an absolute value function. So, and I'm going to go very briefly with this. I'm probably just going to do like 2 examples because there's an entire video that I already did on this, and I don't want to spend too much time because this is just review. But let's go ahead and just do this very quickly. So let's say I have the following. F of x equals 2 times the absolute value of x minus 1 plus 3, okay? Now, in your absolute value, there is something, when you have an absolute value equation, for example, something like this, or rather, I'll just do something like this, and let me go ahead and just take off the lines very quickly. So this point is K, and then this is H, right? So this point here is what we call the vertex, HK. So given that fact, and if we kind of just, okay, so basically this is our HK value, right? And this point is HK, so therefore, knowing that this is of the form 2 times x minus h plus k, our h, this can be rewritten as 2 times the absolute value of x minus the quantity 1 plus 3, right? So our HK value, remember guys, when you have a minus h, your h is not negative, it's positive, okay? So be very careful. This is 1 comma 3, so your vertex is 1 comma 3. Now your what is it called, your slope, this part here is your slope. So your slope is m equals 2. So you're going to go up 2 and to the right 1. And you're going to go, now when you're doing absolute value, you have to do the opposite. Because you can draw like a little dashed line here, a dotted line, and say, well, this is your axis of symmetry. So you in reality, what you want to do, you want to reflect over this line, over this dashed line. So you're going to go 1 and then 1 again. So it's going to be right here, right? And that's how you would do it. Give me a second, guys. Okay, so now the last thing that you're gonna do is you're gonna go ahead and just trace the 2 lines, like make the V shape, right? So right here, like this, and then you're gonna do like this, and you want to go, make sure you go all the way up. Okay, hold on. Okay, so this is how you would graph it, and then you would just say that this is the function, how it's graphed. Now, let's kind of change it up, okay? Let's say that let's say we have, I don't know, something like f of x equals negative 1/2 times the absolute value of x minus 1 plus 1, okay? or actually, let's do x plus 1 minus, or plus, let's do plus 3, okay? We're just going to do that. And then, so again, I mean, you can do it one of two ways, okay? You can make a, what is it called? You can either make an XY table, or you can do it the way that, you know, they would tell you to do it, which is find the vertex and just do the slope. So, okay. Wait, let me, hold on. Okay, it's 15 minutes. Okay. So, again, your vertex, so there's a huge difference with this one. We have the following: -1/2 times the absolute value of x plus 1 plus 3. We want to change it to this, right? And how do we say, so one of the things that we notice is that we don't have a minus h, we have a plus h. So then you think, okay, well, how do I change that from x plus h to x minus h? Well, you can go ahead and say -1/2 times the absolute value of x minus h plus k, right? And then you can say -1/2 times the absolute value of the quantity x minus, and then we know that since we have a plus h, or rather an x plus 1, this is really equal to x minus -1. This is what we call an identity, okay? Meaning that they're both the same thing. So we can say x minus -1 plus 3. So now we have our vertex. Our vertex, this is h, this is k, so our vertex is -1, 3. So we can plot that in our graph. So -1, 3, right? And now we look at the so from there you can say, okay, well, I can say that the axis of symmetry is x equals h, even though I know I don't think they do axis of symmetry with absolute value functions, but it's good to do it only because you want to make sure you reflect like your points. So our slope is -1/2. That's our slope. You're going to go down 1 and to the right 2. So it's going to be right here, and then it goes 1, 1, 1, 2, 1, 1, 2, 1, 1, 2, and then that would be it. And then you would just reflect it. So it would go 1, 2, and then it's 1, 2, right? 1, 2, 3, 4. Let me do that again, actually. Hold on. It goes 1, 2, 3, 4. 1, 2, 3, 4, right? And so it goes 1, 2, 3, 4, 1, 2, 3, 4, right? That's how it would be. And then so then it would be right here, right? And then you would say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Really, it would be over here, but it's off the grid. So you don't have to do, like... I mean, you wouldn't have to do all of it. In reality, it would look something like this. So you would just do... You would just trace the lines now. So, like, do the straight lines. And then from there to there, and then from here to here, right? So and you can also like erase the little dashes once you're done with that part. So it would just be looking like this, and then this would be kind of your absolute value function. This is how you would graph in, right? So that's really brief. I'm not gonna go over like crazy how to graph more because I don't want to make this video too long. But that's how it is. That's how you graph them, right? And so now they teach you, so then after that they teach you, okay, well, now that we know how to graph absolute value functions, not equations, functions, we want to learn how to solve absolute value equations because that's very important. Also, well, actually, never mind. I'll teach vertical stretch and shrink once we get to quadratics. But so for absolute, so now it's absolute value equations, right? And there is one part that I did forget to go over. That was literal equations, but I will go over that very soon. The main idea of algebra is functions. That's the... I mean, literal equations, yes, those are very important, but I don't want to, like, do... Those are a very, like, small part of algebra. So yeah, those aren't even looked at once you do, like, once you go into pre-calculus and calculus and trig and stuff, those are not really looked at. Because in reality, literal equations are just making sure that you understand how to manipulate variables. That's really all it is. Anyways, absolute value equations. So now there's a special rule for absolute value equations, and like there are some that don't have any real solutions. Others do have a solution, or rather well, that's more than inequalities, but we'll get to that when we get there. So for example, if we have the absolute value of x minus 3 equals 4, that means that, so there's a whole rule. If you have the absolute value of x minus h equals r, then x minus h equals r, or x minus h equals negative r, right? So therefore, if we have this, the absolute value of x minus 3 equals 4, you're going to say two things: x minus 3 equals 4, or x minus 3 equals negative 4. And sometimes they're going to want you to know how to actually graph it on the number line. So what you're going to say is, but that the whole thing with, I mean, not like to graph it on the number line, what I mean by that is when it comes to absolute value inequalities. They're going to want you to know how to do that. So then we have x minus 3 equals 4, or x minus 3 equals negative 4, and then for the first one, you add 3 on both sides, you get x equals 7, and then for the other one, you add 3 on both sides, and you get x equals negative 1. Now you check it. The absolute value of 7 minus 3, is that equal to 4? You do, not negative 7, I meant positive 7. You would do, okay, so then you would say the absolute value of 7 minus 3, that's the absolute value of 4. Is that equal to 4? You say 4 equals 4, and you say, okay, that's a good one. That's the correct answer, right? The reason why they ask you to check it is because sometimes when you get solutions, it can be a possibility that one of them is extraneous, meaning that one of them is not a real solution, or one of them does not satisfy the equation. So for this other one, you would do the absolute value of negative 1 minus 3. Is this equal to 4? So then you get the absolute value of negative 4 equals 4, and that means that 4 equals 4, so then you're done. So your solutions are x equals 7 and x equals negative 1, right? Now, let me do another one. I'm trying to think of more that I could do. Just maybe 2 more for this part, because I really don't want to do like a whole, like I don't want it to be really, really, really long. I'll do 3 more for the sake of relearning. So give me 1 second, guys. Okay, so let's look at this one. We have 2 times the absolute value of 2x plus 4 equals 4, right? So one of the things that you're going to do is, number 1, notice how we have our a value, and we're going to go ahead and take that off, right? What you never do in this case is, okay, hold on, give me 1 second. So one of the things that you never, ever do in this case is you never, ever want to say that, so this is kind of an error, okay? Let me label this in red. Okay, this is not correct. You never want to change the 2 to a negative, or even if you have like the absolute value of x minus 4 equals 2, and I'm trying to think. Yeah, and then you say, oh, that means that x minus 4 equals 2 and negative x minus 4 equals 2. No, please don't do this, okay? This is wrong. You don't want to mess, you never mess with the absolute value bars. Like, these lines are here for a reason. Think of it as like they're kind of like sticked to the function. You don't mess with that function. You don't mess with the inside. Do not mess with whatever's inside the absolute value. So then all you do though is you just divide by 2 on both sides. You get the absolute value of 2x plus 4 equals 2. So then you have 2x plus 4 equals 2, or 2x plus 4 equals negative 2, right? Anytime you have, like I said, anytime you have something like this, you want to say x minus h equals y, or x minus h equals negative y, right? That's how it works. I can use a different value other than y. I can say that it's negative a, or a, and then x minus h equals negative a. That can be another way to say it. But my point is that when you create the two equations, you always want to make sure that it's positive, that it's equal to the positive and the negative part, okay? So then moving on, we have minus 4 on both sides. You have 2x equals negative 2. You divide it by 2 on both sides. You get x equals negative 1. Over here, you subtract 4 on both sides. You get 2x equals negative 6. You divide by 2 on both sides, and you get x equals negative 3. So then you check them, right? You check them. Check x equals negative 1. So then you have the absolute value of 2 times negative 1 plus 4. Is this equal to 2? You do negative 2 plus 4, the absolute value. Is this equal to 2? And then you say the absolute value of 2 equals 2. 2 equals 2, so you're good. So x equals negative 1 x equals negative 1 is a solution. Excuse me. And then for the other one, you got x equals negative 3. So you would say, okay, so check x equals negative 3. X equals negative 3 is, so basically you do 2 times negative 3 times the absolute value, or it would be the absolute value of 2 times negative 3 plus 4. Is this equal to 2? Or, right, is this equal to 2? So then you say the absolute value of negative 6 plus 4 equals 2. So then the absolute value of negative 2 equals 2, which is a true statement. So therefore, your solutions are x equals negative 1 and x equals negative 3. Okay. So let's move on to absolute value inequalities now. Absolute value inequalities, there are some, and there are like special rules to this kind of, like, how do I say it? There are special rules to this kind of like skill, right? Or this topic. Number 1, so 1, so what was I gonna say? Oh my goodness. So, I mean, honestly, with absolute value equations, you can always check to see if they're solutions, and then if they're not, it'll tell you once you check it back in. Inequalities, so there are certain ones that where you do it and then they tell you, like, there's certain ways to know how to like whether or not they have a solution without even working it out. Now, of course, when they are quizzing you, or when you're doing an exam, in the world of math, a professor never likes, or a teacher never likes to see that the student did not show any work. including myself, because, you know, even though I'm not a professor or a teacher, I would hate if I was a teacher and one of my students did not show work for whatever he did. Trust me. Once, you know, if you're studying math, or if you have to learn math for whatever you're doing in your career, there are going to be classes, and, you know, there are people that take calculus and stuff, and basically what I'm trying to say is always make sure you show your work. So, yeah. How that connects to this is basically the fact that I do not want anybody to do any kind of absolute value inequality or equation without showing your work. Like, get the answer without showing your work. I don't want anybody to do that. So, let's go ahead and do one. Okay. Now, you can do, so this is a perfect example of what I'm talking about. This one, so this one has two things. When you have an absolute value, what is it called? An absolute value inequality, you're going to get two things. X minus h is greater than y, or x minus h is less than negative y. So, how it works with absolute value inequalities, you change the sign and you make whatever you change this sign here, and then you change the sign of the number that is next to the inequality. So, this would be x minus 3 is greater than 2, or x minus 3 is less than negative 2. Now, you want to go ahead and say, okay, if I add 3 on both sides, right, and there's always a way to check this once you're done with it. If I add 3 on both sides, I get x is greater than 5, or, and then I do the same thing to the other one, add 3 on both sides, I get x is less than 1. So, let's just say, you know, let's just say that, let's try to make this, a, what is it called? Let's try to make this an equation, right? So, if I said x minus 3 equals 2, get x equals 5, x minus 3 equals negative 2, you get x equals 1. The absolute value of 5 minus 3 equals 2. Now, if I said x is greater than 5, okay, I can say, okay, 6 minus 3 is greater than 2. The absolute value of 6 minus 3 is greater than 2, right? Because in reality, what you're looking for is not that they satisfy these two equations, but that they satisfy the absolute value, or not that they satisfy these inequalities, but that they satisfy this absolute value inequality. So you're going to say 6 minus 3 is greater than 2. So you're going to say, okay, the absolute value of 3 is greater than 2, so then that means 3 is greater than 2. So x is greater than 5 is a solution. And then you do the absolute value of 1 minus 3 is greater than 2. Or, excuse me, it would be x is less than 1. So let's say we plug in a number less than 1. So if we do the absolute value of 0 minus 3 is greater than 2, so it would be the absolute value of negative 3. The absolute value of negative 3 is greater than 2, so then it would be 3 is greater than 2, which is a true statement. So x is less than 1 is also a solution to the equation. So your solutions, now if you want to write this in interval notation, not that they would ever make you do this, but if you do want to write this in interval notation, now remember, like I said in a few videos ago, I said you cannot write 5 is less than x is less than 1. This is not an inequality. You can write, so basically your solutions are, if you write this as an interval notation, you would say, okay, it would be from 5 to infinity, and this would be from negative infinity to 1. Now, if they asked you to graph it, if they asked you to actually graph this inequality, you would say, okay, let's graph this inequality, and you would say, it would be from so basically you have negative 1, negative 2, negative 3, negative 4, negative 5, so on and so forth, right? So then it would be from negative infinity to 1 without actually counting it, so it would be an open circle at 1, negative infinity to 1, and then, oh, excuse me, it's positive 1, not negative. Give me a second, guys. Okay, so it's negative infinity to 1, right? And then you go from 5 to infinity, so then you would go over here. Hold on. I don't know why. It would be from 5 to infinity, right? So that's how you would graph it, if you were to graph it. And if they really want you to write it in interval notation, the way you would say it would be negative infinity to 1 union 5 to infinity. Okay. So that's how you would do it. I'm trying to think of what else. Absolute value inequalities, you don't really have to, like, you don't have to know, like, I don't think you have to know, you have to do it in interval notation. I really doubt it. I think the professor will be just fine with you saying, oh, x is less than 1, x is greater than 5, and then you just go ahead and, oops. and then you just go ahead and what is it called? Graph it. Sorry guys, I'm like really slow. But yeah, basically this is how you would do it. So I think that concludes this video, because obviously we did graphing right here, and then we also did solving an absolute value equation and an inequality. Let me just do one more. I'm gonna just do one more, just for fun's sake. Okay. Let me actually, hold on. I'll do 5. 5. Okay, so this is an interesting one. This is the last one I'm gonna do for this video. Because it's almost 50 minutes and I don't want to do it. I don't want to overdo it. So, this is an interesting one. I know that for some people it's easy to see, and for people like me, it's easy to see that this, you know, obviously right off the bat, just from looking at this, I would say, or let me actually, hold on, let me actually do -2, that's better. -2 times the absolute value of x minus 3 minus 1 is greater than 5. So right off the bat, just looking at this, I see that there is no real solution. It cannot be greater than 5. And I will tell you why. Because if you do a sketch, a very rough sketch of the function 1, 2, 3, and then let me just take off the rule lines really quick. 1, 2, 3, and then it's -1, right? So this is your vertex. Now you notice that it has a slope of -2, so it's going to be facing down. So it's like 1, 2, 1. Or, hold on, no, it's... Actually, no, I'm right. 1, 2, 1, right? 1, 2, 1, 1, 2, 1. So on and so forth. So then you do this, right? And then you do the reflection. This is your reflection, right? So then you do this. Now, can this function be greater than 5? If you graph 5, if you graph y equals 5, can this be greater than 5? If you think about it. So, for example, let's say we have something like y equals 5, right? So then that means we have, at the line y equals 5, we have 0, 5, 1, we have 0, 5, 1, 5, 2, 5, 3, 5, etc. Dot, 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 right? So, I mean, honestly, and then if I say, okay, at y equals 5, if I look at this and I say, okay, at y equals 5, you solve for x, right? Negative 2 times x minus 3 equals 6, and you get negative 2. You divide by negative 2 on both sides, you get x minus 3. The absolute value of x minus 3 equals negative 3. X minus 3 equals negative 3, or x minus 3 equals positive 3, right? You add 3 on both sides. You get that x equals 0, or x equals 6. And then you check it. You say, okay, well, negative 2 times the absolute value of 0 minus 3 minus 1 equals 5. So then I say, okay, negative 2 times the absolute value of negative 3 minus 1 equals 5. Negative 2 times 3 minus 1 equals 5. Negative 6 minus 1 equals 5. Negative 7 equals 5. Negative 7 does not equal 5, so therefore this solution cannot work. If you do negative 2, so if you check x equals 6, negative 2 times the absolute value of x of, not x, 6 minus 3 minus 1 equals 5, right? Negative 2 times the absolute value of 3 minus 1 equals 5. Negative 2 times 3 minus 1 equals 5. Negative 6 minus 1 equals 5. Negative 7 equals 5. We get it again, right? So then you look at it and you say, okay, they're not both solutions, so therefore it's no solution. Okay, there's no real solution. Same for this. That means that it cannot be greater than 5. If it's not equal to 5, why would it be greater than 5? You know, unless this was a positive. If this was positive, then yes. Because if the negative 2 was positive, then it would be going upwards. And you would say, okay, well, yeah, it would be, because, you know, you would obviously cross the line. But because it's upside down, there is no intersection between both of these. So therefore, this equation, or this inequality here, has no solution. Okay? Alright, guys. That concludes this video. I know that it was quite a long video. In the next video, we're going to be learning how to do quadratics, and we're going to be reviewing quadratics, parabolas, vertex, how to evaluate a quadratic, or actually how to graph quadratics, and quadratic equations, quadratic inequalities, all that good stuff. So please stay tuned, guys, and thank you so much for watching, and I hope you found this very helpful. And with that being said, guys, I will see you guys in the next video. Please make sure to like, comment, and or subscribe. Thank you.